Morning all. So today in this session we'll be dealing with the instrument transformers. So in the previous classes we have studied about the single phase transformer and its applications and what is the working principle, phasor diagram, everything. So today we are studying about another type of transformers. So because in the first class I have told you about there are different types of transformers, and one is distribution transformers and another one is instrument transformers. So instrument transformers are actually used for measuring purpose, because when we go outside, you can see that we will be talking about CT and PT. So CT is the current transformer used for measuring high current, and PT is the potential transformer used for measuring high potentials. So how we do that, we will see now. So basically, the instrument used for the measurement of quantities are called measuring instrument. So it can be a ammeter, it can be a voltmeter or wattmeter, any measuring instrument. Okay, now the key point is here, the transformers used in conjunction with the measuring instrument. So these measuring instruments, they cannot take these high values. They cannot take the high value of current, or they cannot take the high value of voltage. So we use a transformer, and we will step down the high current or high voltage, and then we measure it. Such transformers are called instrument transformers. So mainly we measure high current, or we measure high voltage. So for measuring high current we use current transformer, and for measuring high voltage we use the voltage transformer. Okay, so both the transformers are used for step down of highly rated current and voltages. Okay, high current transformer for highly rated current and voltage transformer for highly rated voltage. So voltage transformer is also called the potential transformer. Potential means voltage, right? Yeah. Okay. Moving ahead. Okay, a practical example is like a standard secondary current rating of a CT is 5 ampere. I told you, high current will come to the primary, and the current transformer will step it down to a nominal range so that the ammeter can measure it. So normally it will be 5 ampere, and the secondary standard voltage rating for potential transformer will be 100 or 120 volt. It will be 100 or 120 volt. The secondary side. Okay, now we will move in detail to the current transformer. So this is basically the figure of a current transformer. So it will be connected in series with the transmission line, because current measuring instruments will be connected in series. So this, you can see that this is the primary. Having N1 number of turns, the number of turns in the primary is less, and the number of turns in the secondary is more. So what will happen? Current will be less, right? Because this current and voltage, they have an inverse relation in case of a transformer, right? The main function of a current transformer is to step down a high magnitude alternating current. So high magnitude alternating means the AC current, AC sinusoidal current will come here, and so that it can be measured by a low range ammeter. So why we are stepping down? We step it down so that it can be measured by a low range ammeter, and so it is giving protection against high current. So current here N1 at N1 will be very high, and when it reaches N2 the current is step down. So the main function of a current transformer is to step down a high magnitude alternating current. Okay, so by stepping down the high rated alternating current, so stepping down the current, what they are doing? They are actually providing protection. So current magnitude is less means it's a protection, right? Okay. A small current proportional to the line current through the secondary of the CT is drawn, right? So in the secondary of the current transformer, I have shown you one example. Now 5 ampere only is coming. So it will be proportional. So in the primary, maybe 1000 ampere is coming. So that 1000 ampere will be proportional. So it is depending upon the number of turns, right? So only that much current will be coming in the secondary. So that is the current transformer for you. So a relay connected at the secondary of the CT will sense the abnormal current, and it will protect the system, right? Okay. So this is basically another type of diagram, a practical. I have shown you the core and everything. So this is the conductor and this is the current. So in the secondary current, what the current that we're getting will be based on the number of turns, right? So this will be the current I1, and the current in the secondary I2, it depends upon the number of turns. So if the number of turns in the primary is just one turn, then means the second, it will be 1 by n times the current will be, that only that much current will be here. The primary winding of CT is made up of few turns of thick wire and is connected in series with the power line, and the secondary winding has large number of turns. Okay, you have seen that in your figure. Here current is stepped down and voltage is stepped up, right? In a current transformer, current is stepped down. So when current is stepped down, since the secondary has more number of turns, voltage will normally be stepped up. So basically, a current transformer is a step-up transformer in terms of voltage. When you say about current, it is stepping down. It's stepping down to a small value so that it can be easily measured by using the measuring instrument. So now your transformer basics should come into effect. So consider I1 is the primary current, I2 is the secondary current, N1 is the number of turns of the primary, and N2 is the number of turns of the secondary. And we know that for a transformer, N1 I1 is equal to N2 I2, because we derived that V2 by V1 is equal to N2 by N1 is equal to E2 by E1 is equal to I1 by I2, right? That same equation. This N2 by N1 is equal to I1 by I2. This I1 by E2 is called the CT ratio, the current transformer ratio, the transformation ratio. So the primary to secondary current ratio is called the CT ratio. Very important. This will come as a, this can come to you as a Viva question also. So N1 I1 is equal to N2 I2. So N2 by N1 is equal to I1 by I2. So I1 by I2 is what? The CT ratio. Okay. So I1 is equal to I2 into CT ratio. So normally for a current transformer, they will give you the CT ratio and ask you to find the line current or some example. See this. So line current IL is equal to ammeter reading, because in the secondary only we are connecting the ammeter, right? So what reading we are getting in the ammeter multiplied by the CT ratio will give you the line current. So if the ammeter is 5 ampere and CT ratio is like 20 is to 1 is to 20, because secondary will have more number of turns, right? Then the line current will be, sorry, it is 5 ampere. This is 3 ampere means this is 3 ampere into 20 by 1. This 5 means 5 into 20. Okay. So the key points means the current transformers step down the heavy power system current suitable for operation of relays and measuring instruments. Okay, you already understood what is happening, what is the figure, how they do it, and one practical example also I have shown you. Okay, and they isolate the relays and metering circuits from high voltage of a power system. Understood, right? Okay. Now we are coming to the potential transformer. So as the name says, potential transformer, they measure the voltage. So measuring voltage, what we do, it should be connected in parallel, or what we call shunt connection or parallel connection is essential for measuring the voltage. So this is a voltage transformer or potential transformer. So this is the diagram. This will be the primary and this is the secondary, and we are connecting the voltmeter here. So we can see that in case of a potential transformer, the secondary is having less number of turns, and this is a transmission line, and we are connecting the potential transformer parallel. Okay. So the instrument used for the transformation of voltage from a higher value to the lower value, okay, that is potential transformer, and this transformation step down the voltage to a safe limit value, which can be easily measured by the ordinary low voltage instruments like a voltmeter, wattmeter, watt-hour meter, right? Voltage, power, and energy, total energy measurement. Okay. So the primary winding, in case of a potential transformer, it will be having large number of turns, that is connected to the high voltage supply, and secondary winding is connected to a low range AC voltmeter. It will be having only few number of turns. So The primary winding is connected across the high voltage line whose voltage is to be measured. That is V1 is equal to line voltage and V2 is equal to the voltmeter reading. So just like the transformer equation, we have V1 by V2 is equal to N1 by N2. So V1 by V2 is the PT ratio. There it was I1 by I2. Here V1 by V2 is a PT ratio, or what we call the transformation ratio. So V1 is equal to V2 into PT ratio. So if the wattmeter reading is 1 volt and the PT ratio is 150:1, then the line voltage will be V1 is equal to same, just multiply. Yeah, that is a voltmeter. So just understand the difference between CT and PT and what they do. Okay. Now you can take the key points for potential transformer. That is, it is used for a metering purpose. Okay, both CT and PT they use for metering purpose. One for the current and one for voltage. And for the protection of feeders, how they protect it? By stepping down the voltage or stepping down the current. They protect it. How do they step it down? You know, one will be connected in series, one will be connected in parallel, and depending upon the number of turns, we are getting the current step down, or if the number of turns, like in case of a potential transformer, we are getting the voltage step down. Okay. So the potential transformer needs to be connected in parallel because we need to measure the voltage, and current transformer is to measure the current. So it is connected in series to the conductor carrying that current. Okay. So that's all about the potential transformer and the current transformer. Hope you might have understood. So what you should understand, because you can get numerical problems also based on this. So you should understand what's the current transformer, what happens in the primary and what happens in the secondary, which has more number of turns and which has less number of turns in terms of PT as well as CT. It is very important. Okay. And that practical example with the values also I gave you, that also you should study. Okay. Okay. I hope the topic is clear for you, and the diagram is also important. Okay. Okay. Thank you.